In the heart of Cairo, Egypt, a prestigious research center is designing an innovative and sustainable laboratory building. This state-of-the-art facility, spanning 2,515 square meters, symbolizes progress and excellence. With a clear objective in mind, we, as a team from Universitas Indonesia, aim to prioritize well-being and sustainability and exceed regulatory standards. We aim to achieve net zero energy and net zero emissions, surpassing even the highest expectations.
With cutting-edge technologies and frameworks, we embrace a powerful approach. Our performative facade and energy-efficient equipment reduce energy demand, creating harmony with the environment. Other than that, integrating renewable energy sources unlocks significant carbon reduction potential. Together, we pave the way to a greener future through passive design, active design, and sustainable practices.
The selected site is based on ASHRAE Standards 189, Site 7, which is located at Al Koba Bridge, Awali, Cairo, has an area of 10,600 m². We choose this site based on the selection results of 9 sites that have the potential to be selected as development area for this building project. The selection of the 9 sites is based on the allowable sites.
Our selected site is located in hot dry area whose climate zone is 2B. In this site, the highest solar altitude is 77.64 degrees on summer and the lowest solar altitude is 39.84 degrees in winter. Based on weather data, mostly the wind comes from the north side with an average wind speed of 4.4 meters per second. Talk about temperature. The hottest month of the year in Cairo is August, and the coldest month of the year in Cairo is January.
This location is situated on Nasser Road, a significant road that is easily accessible by public transportation. There are 2 bus stops in the vicinity, while the nearest metro station is El Abbasiyah Station, which is only 350 meters away and making it easily accessible on foot within approximately 6 minutes. This design aims to creating pedestrian-friendly communities and promoting sustainable transportation alternative in this area.
Our building has been rotated 41 degrees from the baseline model. The consideration of this orientation is to minimize the direct sunlight that penetrates into the laboratory area and adapts into the site area shape.
Greenfield site after development experienced an increase in native plant area by 29.4% from 6.6% previously. This has reached ASHRAE Standards 189 if less than 20% existing native or adapted plants. The mitigation of transportation impacts, we try to design according to the standard ASHRAE 189.1 regarding pedestrian and bicycle connectivity. About bicycle parking space shall be provided for at least 5%, and we have 30 bicycle parking space at the site has exceeded 5% of the building's occupant load of 402, and we have electric vehicle facilities available on the site, which consists of 4 spaces out of the 20 available car parks.
The building site hardscape design complies with ASHRAE Standard 189.1, which relates to the site hardscape.
The hardscape on the site includes the utilization of permeable paving on the pedestrian side, covering 797.5 m² and equipped with shading devices from building structure and vegetation surroundings.
To achieve the use of renewable energy on site, according to ASHRAE Standard 189.1, 46.6% of this roof covered with PV, BIPV, and solar collector to provide all of the building's energy needs. The remaining area of the roof is covered with a green roof with a total area of 1,177.8 m², which is filled with native plants from Cairo. The green roof's existence serves to mitigate the heat gain generated in the dry bench lab and high data server room located on the right side of the building's mass. The building's facade was modified to achieve 3 goals. First, to optimize the flow of wind, optimizing the natural light, and minimizing solar gain to the building. Our intervention to the building, we designed the shape of the facade by incorporating diagonal lines on the north side to direct the wind from outside to inside. To reduce energy consumption from the HVAC system, we also integrated the facade with a wind catcher for the atrium and offices to support the rooms with natural ventilation. The wind catcher contains modules that adapt the Masharbiya pattern from Cairo. The inlet modules are filled with a cooling coil, which brings cool air inside when the wind enters. The form of the facade is also adaptation from the arches commonly found in Cairo's buildings. The arches are extruded 3 meters from the building, serving as a shading device for pedestrians. This design strategy not only enhances the building aesthetic, but also providing functional benefits.
The material used in this building has several layers in an effort to reduce heat. One example is the optimization carried out in the selection of material for walls, which can reduce heat in buildings by up to 23%.
Our proposed design controls the daylighting that penetrates into the building through stone facade. The facade decreases the average lux from 4,435 lux, which is the baseline design, to 776 lux in the proposed design. We use natural ventilation in the office and atrium to cool these rooms. Utilizing an integrated wind catcher on the upper side of each room, the airflow has a wind velocity range between 0.8 meters per second and 1.6 meters per second in office rooms. Atrium also uses an integrated wind catcher that has wind velocity range between 0.6 meters per second and 2.6 meters per second at eye level height. This wind catcher plays a significant role in regulating airflow, so several rooms can utilize natural ventilation.
With 2 levels and 15 meticulously adjusted HVAC zones, this building showcases the art of spatial optimization. An impressive net floor area of 2,871 square meters boasts a total condition area of 1,910 square meters, accounting for 66% of the building's total area. Our temperature and humidity settings follow the esteemed ASHRAE standard 55, ensuring optimal conditions for everyone. Through simulation statistics using Design Builder, we've achieved an average PMV and PPD of 0.16 and 7%, indicating outstanding thermal comfort. Introducing our advanced lab ventilation system, it starts with the ASHRAE's minimum ventilation rate, precise temperature control, and ideal humidity set point. But we go beyond that. With LVRA and ASHRAE Standard 62, we ensure top-notch indoor air quality throughout the lab and non-lab areas. But here's the game changer. DCV adjusts airflow based on CO2 level, slashing energy usage by 57% compared to CAV system, and meet our high-performance low-flow fume hood that cuts energy consumption from the fan system by 40%. With adherence to ASHRAE Standard 170 and 62.1, our system customizes ventilation for your lab's needs while keeping occupants comfortable. Our facility uses VAV system for enhanced control and energy efficiency. Heating is provided by a zero-emission radiant electric system, while our cooling is powered by a solar thermal cooling system with an absorption chiller and solar collector. These innovative measures result in up to 85% and 86% savings in cooling and heating energy consumption. Our optimized HVAC design, including a DCV system, not only improves energy efficiency but also promotes sustainability.
In lab safety is crucial. Our ventilation system that follows ASHRAE standard for COVID-19 and ASHRAE classification of laboratory ventilation design levels delivers 100% fresh air with MERV 13 filters or higher. UVGA technology is used to sterilize coils and surfaces. In non-lab areas, HEPA air cleaners enhance air quality by prioritizing air quality and incorporating innovative technology. We create a healthier and more efficient laboratory environment, ensuring safety, comfort, and sustainability.
Precision and accuracy are paramount when estimating the building's power requirement. We use the space-by-space method following the ASHRAE Standard 189.1 guidelines to accurately estimate the building's power requirements. We also match the owner's project requirements to each floor's ASHRAE equivalent space types, ensuring precise power estimation. Unlike the simplified building method, which overlooks space type, occupancy, and function, the space-by-space method provides a detailed estimate of power demand. The results are astounding. The space-by-space method yielded a remarkable 63% reduction in electricity usage compared to the simplified building method.
Occupancy sensors are crucial components of sustainable building design for energy efficient lighting in this building and consider an important parameter. The max allowed lighting power is chosen under the ASHRAE 90.1 standard and the ASHRAE laboratory design guide. As you can see, the optimization results show a 34% gain in efficiency with efficient light and a 58% increase with the addition of an occupancy sensor. Water is a precious resource, particularly in dry countries like Egypt. According to the book Water and Development in Greater Cairo, Egypt has limited water supply due to its arid climate. This building has taken steps to minimize water consumption through technology and fixture selection, recognizing the importance of preserving this valuable resource. This building requires 3 million liters of water per year, thanks to a municipal water supply of 2 million liters per year from the Nile River and ASHRAE condensate recovery of 1 million liters per year, which follow ASHRAE standard 189.1. Did you know that 60% of household wastewater comes from sources other than toilets? But here's the good news. We can recycle this grey water for non-potable uses. One effective method is using a membrane bioreactor technology. MBR combines biological process and membrane technology to create safe, high-quality water for reuse. Our optimized system uses greywater reclamation and water-efficient fixtures based on ASHRAE 189.1 and is certified by the APA with the water sense label, saving up to 20% more water than standard products. Simulation results show a potential water consumption reduction of 15% and cost savings of up to 25%. Adopting this practice not only significantly reduces water usage but also saves money.
Building automation system saves energy by automatically integrating lighting, HVAC, fire alarms, and access control. ASHRAE recommends BACnet for optimal lab performance and resource utilization. BAS also offers centralized monitoring, control, and risk reduction for desired environments and increased productivity. BAS optimized lab operation for a greener, smarter, and more sustainable future, paving the way for an intelligent world.
Waste management in buildings, both solid and liquid. Solid waste is divided into organic waste, paper, plastic, and other. Organic, paper, and plastic waste will be sent to the garbage collection site in Nansiat Nature with a distance of 6.1 km in 11 minutes from building project. Meanwhile, liquid waste such as sink, shower, and outpollution water will be processed at the recycle treatment plant. In addition, toxic and hazardous waste from the laboratory will be collected and stored at a certified company for processing.
Safety is our top priority with advanced fire protection system complying with ASHRAE and local standards. Our design are interconnected with the National Fire Protection Association for comprehensive fire safety. Our system includes ABC powder extinguishers for Class A, B, and C fires, with additional D powder for rare Class D fires. The fire hydrant systems provides a reliable emergency water supply, while the compact fire hose rail cabinet system offers accessible response equipment. Clean agent fire suppression system protect without harming the environment, and the extinguishing control panel ensures centralized control. The abort and manual release station allow manual activation of safety measures. Swift response and safe evacuation are ensured with emergency lighting, audible noise, and photoluminescent strips throughout the building. Other than that, our comprehensive fire detection system also prioritizes early detection and swift action.
On passive fire protection system, we did some changes to the layout of the fire exit. According to the simulation result, these changes reduced the evacuation time from 207.5 seconds to 97 seconds.
Our lab building is a powerhouse of energy efficiency. By strategically managing components like heating, cooling, fans, pumps, lighting, and plugs, we've reduced energy consumption by an astonishing 75%. But that's not all. We've surpassed EUI target for Cairo's Climate Zone 2B with remarkable improvement of 87% in source EUI and 69% in site EUI according to ASHRAE Standard 100. These numbers speak volumes about our unwavering dedication to energy conservation.
In our pursuit of green building practices, renewable energy utilization is crucial, especially through PV solar panels. ASHRAE Standard 189.1 mandates renewable energy use based on gross roof area. Using PVC software, cutting-edge technology, and 26-degree south-facing panels, we achieve an impressive 272 kW peak PV capacity. This generates 461 MWh of energy annually, covering 85% of our building's energy load, surpassing it from April to October. Surplus energy is fed back into the grid, contributing to Egypt's renewable energy revolution. In conclusion, PV solar panels meet ASHRAE 189.1 requirements, reduce reliance on traditional sources, and promote environmental conservation and sustainability.
Life cycle assessment, or LCA, is an evaluation process that reduces a structure's carbon payback period. LCA calculations between building baselines and optimized buildings reveal a considerable increase of 57%.
LCCA is an essential investment tool that considers all project costs. The proposed building's capital expenditure for mechanical system is 25 million Egyptian pound compared to 16 million Egyptian pound for the baseline. Sustainable and eco-friendly buildings may require higher upfront investment, but result in lower annual costs, making LCCA a cost-effective approach. However, the proposed building achieved an impressive 45% reduction in total life cycle costs. This remarkable achievement is made possible through the outstanding energy efficiency.
In Cairo, a prestigious research center's lab building has been designed with sustainability and energy efficiency in mind. By prioritizing green land with native plants, an optimized HVAC system, and a PV system that covers the building's energy load, this building boasts an impressive carbon payback period of 57% and 69% increase in EUI site compared to ASHRAE Standard 100. With a focus on environmentally conscious and comfortable design elements, this lab building paves the way for a brighter and greener future for Egypt.